Hi there, my name is Caitriona Schork, and this is our Netflix and movie TV show analysis capstone project. So the goal of our project was to look at movies and TV shows and analyze the factors that made them the most popular. So we did this by finding an engagement report that Netflix put out last year, and it was their most watched items from January to June of 2023. This consisted of about 18,000 total items. And so first, we're just going to summarize the items in the report. So there were about 6,000 TV shows and 12,000 movies, meaning about 35% shows and 65% movies, as we can see in this bar graph. And this kind of shows that there's a 1/3 to 2/3 ratio between TV shows and movies. And this goes along with Netflix's overall catalog, which contains about 30% shows and 70% movies. So now we're going to look at release date to hours watched, which was put on the overall engagement report. And we can see that from the scatter plot, a exponential increase in hours watched based on year for 2023, which makes sense that the more current items are being watched the most, but we can kind of see this gradual increase starting from around 2016 to 2022. And so now we're going to analyze this using statistics. So our null hypothesis is that there is a difference, or that there is no difference in hours watched based on release date. Our alternative is that there is a difference. And then based on the p-value of 1.8 to the negative 10 to the negative 40, we can see that at all normal levels of alpha, there is very strong evidence to support that there is a difference, and that is not by chance. Based on the R value, there's no linear relationship, but we can kind of see that here that there's probably an exponential relationship. So moving on, we wanted to take the top 100 items in this engagement report and analyze them on a few different factors. So first, we're going to start with genre. So this is just calculating the total hours watched for each genre and then finding out the proportion of hours watched for each genre. And then we also wanted to find out if that kind of matched how many number of each genre in terms of count based on the top 100. So in this bar graph, we can kind of see the differences between the hours proportion and the count proportion. Most of them are about even. Thriller was kind of the most significant, where there were more hours in terms of the proportion compared to the count. But clearly we can see that drama is the most popular genre in terms of most watched. Then we have thriller, and romance and action are kind of equal. So then we want to move on to rating score analysis. So we looked at IMDb score, tomato meter, and audience score. So IMDb score, we can see that there is no linear relationship, and that follows the R value here. Also, the p-value indicates that there is very strong evidence that we can't reject the null, so that there is no difference in the hours watched and IMDb score. This kind of follows along with all three of the types of scoring, as we can see here: tomato meter score and hours watched. There's going to be no linear relationship, and our p-value shows us that there is not enough evidence to support the alternative that there is a difference between hours watched based on tomato meter score. Finally, we have the audience score and hours watched, which follows the same trend, no linear relationship, and our p-value is not significant. So now we wanted to dive deeper into the relationship between the two types of Rotten Tomato scores. So we have tomato meter, which is by critics, and then audience score by verified audience members. And we can see a pretty moderate to strong linear relationship between these two factors. As we can see in our calculated R value, it's about 0.7, which is a pretty strong linear relationship. And then our p-value of 9.5 times 10 to the negative 12 indicates that there is very strong evidence that there is a difference in audience score based on tomato meter score. So that did not happen by chance alone. Now we want to look at the two types of audience-based ratings, which is IMDb score and audience score. As we can see here, again, there's a pretty strong linear relationship. The R value is 0.72, and our p-value is 9.95 times 10 to the negative 16, which means that, again, we have very strong evidence to support that there is a difference between IMDb score based on audience score. So now we want to move on to the gender of lead actor and rating score analysis. So we just kind of wanted to see if the gender of the lead affected how the ratings were. And so these are the averages for each of the gender of the leads. We have co-leads, female leads, and male leads. Co-leads are going to be the lowest ratings. That could be just because there were fewer co-leads in the top 100. And then female and male leads are pretty similar, although male leads do have a slightly higher rating for all three of them. And then we can visualize this in a bar graph. We can see co-leads have the lowest scores, and then male and female leads are about equal, but we just wanted to see if there was a significant difference. So for tomato meter, we can see that there's no linear relationship, and our p-value indicates that there's not a significant difference based on tomato meter score. Again, this is true for audience score, no linear relationship, and our p-value is too high to indicate that there is a difference for audience score. And finally, this is true for IMDb score. There is no linear relationship, and our p-value is not significant, meaning that we cannot reject the null, that there is no difference in IMDb score between females and males. And so now my partner is going to analyze some other factors.
Hello, my name is Srinidhi Pinni, and this next part was coded by me. So the first section we have is the gender of the lead actor versus the hours watched. So for this, what I did was there were three different entries I had to do in the top 100 list, which was male, female, and both, because there are shows that are oriented around two people, such as reality shows or love shows. So that's why I have three columns here: female, male, and both. And then um, I made sure to have each one as a different color, and I did that right here. Um, and that's because I didn't want to like get anyone confused, thinking that these two are the same or these two are the same. But when I looked at this, I noticed that the female column is a lot lower than the male column, which proved my hypothesis that male-oriented movies or shows are more viewed than female-oriented ones. However, something interesting that I noticed was that in the top three movies, I believe in second or third place, it was a female-oriented show called Ginny and Georgia. And that was pretty interesting, but overall, the male-oriented shows did have a higher bar because more people or there are more hours viewed for this show. The next section is a scatter plot between the budget of the movie and the show versus the hours watched. And I divided this into two sections because the budget was really hard to work with. As a lot of you may know, the shows and movies are their production studios don't publicize the budget. That's why a lot of the budgets I got were from Reddit or Quora posts or from BuzzFeed, so not credible websites. But that was what I had to work with, and I only found the budget for 46 out of the 100 entries we had. So for the other blank entries, what I did was I took the average of the budgets I already had and I put that into the blank spaces. That way Python could read it without having any blanks. And I mentioned that here, using the average and putting it in the blanks. So for this, what I did was I used Pandas, just like the last one. And I made a scatter plot, but I did not include a best fit line because on this graph you could see there's literally no fit here. Like there's no trend line that could possibly go here. So I did include the equation though, which is right here, because I thought since the line wouldn't really do much, at least the equation would be there. And if you can't tell from the graph, there is like an obvious place where it's my like average points that I put here. So this line, right, like these line of dots are like the average budget that I put in. That's why there's so many right there, which makes this graph not very accurate because the budgets of all the shows that didn't have a budget online, these were the like places where I had to put it at. And it was about like $50 million for the show that I put in. That was the average of all the other budgets that I had. So when I calculated the R squared value, the P value and the T stat value, as shown by these codes, I found the R squared value is really small and the P value is even smaller. The P value is 1.2 to the -20th, and that shows that there is likely no trend. So if we didn't see it in the graph, like you could see it in the numbers, there's no trend because of how small the number of the P value is and the R squared value is. And I just copied the same code right here, except for this version, what I did was instead of taking the average, I just completely deleted the shows or movies that didn't have a budget, and I only ran it on 46 data points. So that's why this one looks less cluttered. So there isn't that like line of dots right here. There's that, but the R squared value, P value, and T stat value are still really low. The R squared value is like by 0.01 higher than the previous one though, but there still isn't much of a trend. The next section is the production studios versus the number of shows. So I made this into two sections also because one section accounted for the different seasons. The next section counted the seasons as one thing. What I mean by that is, let's say AMC Studios made one show, but that one show had 4 seasons. So in this section, those 4 seasons were produced by AMC Studios. But in the second section, as you could see, AMC Studios is gone because I didn't account for the seasons. I just made them all like the seasons into one show, and that was done by this line of code where I just dropped the duplicates, and that way it wouldn't account for different seasons. And the reason why I did different seasons here was because there were Spanish shows where like one season would be produced by one company and a different season would be produced by another company, but that was only like a select few. That's why I made the other section below. But as you could see from this, of the 100 movies and shows, Warner Bros. Did produce 7 of them. And then came AMC Studios and 21 Laps. Again, this one includes the seasons. And in the second one, this is just a condensed version of it. And I did it, and that was the code right here. I said display max rows 10 because the top one might be a little bit too cluttered. So I made it condensed. And in the second one, however, AMC Studios is now gone and 21 Laps Entertainment is now 2. And Warner Bros. Is now 4 because I didn't account for the different seasons. I only accounted for the show by itself. So the show represents all of its seasons. And the next one kind of goes hand in hand, and that's the production studios versus the hours watched. So as you could see, since Warner Bros. Had it produced 7 of the 100 movies and shows, its bar was the highest, and then following that closely was Sony Pictures Television and also Queenfish Productions. So those ones are really high, but if you see like one of them like UFO Table or the Carsey Warner production company, that is like really, those bars are also really small because that was like one show that they produced. And finally, the last section is movies and shows in other languages. So the first part of this just kind of performed a count. So the number of foreign shows like Korean or Spanish or French was 34 and English was 66. And the bar graph showed that the English shows, English and foreign, the English shows were viewed more compared to the foreign shows, obviously because there were more English shows than foreign shows. So that was the end of my presentation. So thank you so much for watching our capstone project.